Hello! Today we're talking about significant figures and we'll talk about upper and lower bounds as well. Significant figures are kind of a tricky thing for a lot of students, including myself, but it really comes down to this thought of precision, and this is what it's all about here. It's how precise you're being when you're measuring something. And the significant figures that you give to someone when you say how long something is or how big something is really what's telling them how exact you were when you were measuring something. And so here I've drawn a line, and I can go ahead and measure it with my ruler, and maybe I tell you, oh my gosh, no, you can see it. Okay, maybe I tell you it's 13 centimeters. And here I've listed two sig figs that tell you, I've rounded to approximately 13 centimeters. Or maybe I can be even more precise and tell you it's 13.4 centimeters. Or maybe if I even had a centimeter stick with even smaller markings in here, down to the millimeters or whatever, I might be able to tell you even more and give you even more precision, like it's 13.442, I might be able to get really precise to you, and that just tells you what kind of instrument I was using to measure and how close I could get to the actual precise measurement of it. And so sig figs have all these different rules that essentially help us understand how precise we're measuring something or how precise a certain number we have is. So those rules are listed here, and I know they're a little bit funky, but really the things that throw us off the most are zeros, right? Those are the things that are basically the trickiest guys to look out for. Everything that's not a zero is a significant figure. And then depending on where the zeros are placed, it tells us something about precision as well. So for example, this guy here, the 0.023 grams or 0.023 grams, the thing here that's telling us how precise we've gone is down to this thousandths place, right? And so the only two digits here that are telling us about the measurement itself are actually these two. This is 2 sig figs. Whereas these two zeros, they're just placeholders for place value. Okay, so they don't matter. Oh my gosh, I keep going off the screen. I'm so sorry, kids. Okay. These zeros don't matter. They're just placeholders for what we have in front of us, okay? Maybe I should mark where I am. Okay. I'll try to stay within those bounds. Okay. But if I were to tell you, oh, this is 0.0230 grams, now this is a placeholder for place value, but this zero, after other digits but to the right of the decimal point, is significant because now I'm telling you I was really precise. This is about how precise I was when I gave you my measurement. Or let's say I tell you I'm 5 feet tall, right? And so I'm 5 feet, but if I tell you I'm 5.0 feet, okay, also 5 feet, that's 1 sig fig. But if I tell you I'm 5.0 feet tall, you now know that I'm 5 foot on the dot, very exact there. And that's an example of where this zero becomes a 2 sig fig. Okay, and that tends to be the trickiest thing for students. Basically, some zeros matter, some don't. That's what it is. And then also when you're asked to round to 3 sig figs, which we do a lot in our class, basically IB always wants 3 sig figs. Let's say you have something like 7,243.1, whatever. All of these end up being significant figures in this example. They're all non-zero. So this originally has 5 sig figs. But in IB, we usually round to 3 sig figs. And so what you do there, you look at your first 3, right? From reading from left to right, 7,240, whatever. And then you look at the number to the right, and this is just like how we round any other time. If this is 5 or less, if this is 5 or more, round up, and if it's less than 5, keep this the same. So this would round to 7,240. And notice, I've just put zeros in where I had these, and because I have a decimal point here, I'm not gonna do this. That would make a sig fig. But this 0 before the decimal point, no sig. These are the only sig figs now. And then another example, maybe I have that. Okay. Ooh, look. 1, 2, 3, 4, 5 sig figs. If I want to round to 3 sig figs, this is what I'm gonna do. I'm gonna look at the first 3 from left to right. This 0 does not count. It's to the left of the decimal, doesn't do anything. Okay, but these 3 are the first 3. 0.12, and then look at that 7, look next to it. Oh, 5 or higher, so I'm gonna round this guy up. Boop, and that's 3 sig figs. And then a last example that tends to throw kids off. Sure. Okay, this is 4 sig figs. And let's say I want to round to 3 sig figs. This is really tricky. If I want 3 sig figs, I'm gonna read my first 3 digits, look to the right. This is a 7, which is higher than 5, so I gotta round up, right? What ends up happening when you have a 9 though, I can't round up a 9, it pushes over into the next one, right? And so then like if I round this up, I'm rounding this up, and then it's just gonna carry over again. So this is actually 0.9, but to keep the sig figs to show, hey, I had more than 3 originally and I'm just rounding to them. But since I'm rounding, I have to keep in mind that, hey, I had sig figs there and then I use these zeros to show that precision there. So this is 0.900 because these round up to be 0 and then it pushed out that 8. That's a really tricky example, but important. Okay. Oh.
Chris Kavanaugh, please report to the counseling office. Chris Kavanaugh, please report to the counseling office. Thank you.
Kavanaugh, classic. I'm just kidding. I have no idea why he's going. Okay. Let's talk about lower and upper bounds. This is something that trips people up too, but really it's again about precision and what you're assuming about a measurement that you're given, right? And so this is important because you have to know your next place value essentially. All right, because let's go back to that example. Where I tell you this is 13 centimeters, right? And let's say you didn't watch me measure it. Let's just say I tell you that's 13 centimeters. Now here's the thing. If I tell you 13 centimeters, this could have been rounded. You don't really know. So what you're going to do, oh my gosh, I'm gonna scream, okay. I'm sorry. It's because my iPad keeps moving. This could be rounded. All right, and if this is rounded from something, then we do what's called our lower and our upper bounds, okay? Because we have to think about, okay, if Miss Paolini tells me that this line is 13 centimeters long, what could she be rounding from? Well, she could be rounding from a number as low as 12.5 centimeters, right? Because then that would round up to 13, and that could be what she's telling me. She could be saying 13, but really she rounded up from this. Or she could be rounding down from something that's as high as 13.5. Because if it was like 14.99, whatever, she would have rounded down to 13. So this is my lower bound and my upper bound for what this measurement could have been. And that's basically what upper and lower bounds are. You think, okay, this is 13. What's my next like half unit? lower than that, in this case, it would be 0.5 of a centimeter. And so you minus 0.5 and you add 0.5. But it's really because where could this be rounded from? As low as this, as high as this. Yeah. I'm trying to think of like another example. Well, I guess another example that tripped me up, it's in the book somewhere. It's about, you're told a circle has a diameter of 5. I don't remember if it's inches or feet. We're gonna say it's feet. I don't remember. You're told a circle has a diameter of 5, and then you want to find the area. Okay? The first thing you do is take the measurement you're told. And here you were told 5 feet, and then use that for your lower and upper bound. Can you see this anymore? No, you can't. Okay. So then I was told 5 feet. So then my lower bound would be 4.5 feet. See, minus 0.5 and plus 0.5, 5.5 feet. And then I'm going to find the area based on that. So the area lower bound could be 4.5. Oh, I also forgot area's pi r squared. So if this is my diameter, I have to use my radius. So take this, divide it by 2, square that times pi, and then divide that by 2, square it times pi. And those would be my upper and lower bound areas. Okay. Take the measurement and do that plus or minus 0.5, whatever. And then the last thing that's kind of tricky is that sometimes it's not like 0.5 of something. Because sometimes it also has to do with the significant figure thing. Let's say, I don't know. I'm just making this up. I really apologize. Let's say I'm telling you that something costs about $10,000 a year. This is my 1 sig fig. And so thinking about what this would have been rounded to for these non-significant figures, where I could have rounded from, it's not plus or minus 0.5 cents. Right here instead, my lower bound would be $5,000, and my upper would be $15,000. So that's where sig figs can also tie into this. Anyway, I don't know if this was useful, but I think I'm gonna call it there. Let me know if you have questions. All your sig fig rules are right here for you in the frame. Okay, bye-bye.